All right, so we are in Chapter 3, Section 1, called Graphing Linear Equations. Just as always, I'm going to start off the video with a little tutorial here, just making sure you understand what you see on your screen. So this is what you will see when you open up your homework, with the exception of just a couple of things, because this is the teacher preview. So the first thing is they don't give me the due date on here, but they will give you one. And for this year, it's going to be every Sunday at midnight. You will always see this attempts section here. This is my first attempt of unlimited attempts. This means I can submit this assignment as many times as I would like, and it will just stay open for me. This particular assignment has 10 questions. That's the maximum. Assignments will have anywhere from 1 to 10, depending on what was available to be assigned. Grading policy is always best score, so whichever attempt is my best one is the one I get to keep. And partial credit is enabled, meaning if I answer 1 of 10 questions, I get credit for the one question, which also has to do with attempts. You can submit your assignments even if you've only answered 1 question out of 10, and you still get credit for the 1, and you can come back in and finish the 9 later. So this is a reminder that once you start your homework, you must finish it before you can work on anything else. What this means is if you do not click the submit assignment button that we will see on the next screen, then it will lock you out of all of your other assignments. So always, always, always get in a habit of clicking that submit assignment button. Does not lock out the assignment on you. In fact, it makes sure that all of the other assignments are not locked out on you. So I'm going to go ahead and click start. So on my screen, you will not see the submit assignment button down here in the bottom right corner, but it should be on your student screen. Again, that's just something they don't show me on the teacher preview. You will see these 3 buttons and sometimes also a calculator up here. But the first one is an explanation. It says you will lose your current question attempt because it's literally going to explain this problem to you. It's going to show you the solution and the answer. So it's not then going to let you come and type it back in. Okay, it's going to explain it to you though, which is a really neat feature because if you're stuck on maybe just this problem, not the entire problem type, but just that problem in particular, you can see it explained. And then you just come in on another attempt and try that problem to get credit for it. Example just opens up this secondary screen, which gives you just a general example of what they want you to do here and shows you how to type in the answer. You can close that. You can open another example if you'd like. It'll give you a brand new one. And you can also message your teacher straight from here so that it'll attach the question and we know exactly where to go and help you. All right. So let's go ahead and get started here. So we're working on linear equations, and in linear equations, we have to work with the coordinate grid, meaning x-axis and y-axis. So they're going to start off with the kind of a basic idea here of find an ordered pair of x, y that is the solution to this equation. So they give us the equation and say find a solution. Well, in this situation, we're not being told what to plug in. In fact, we have to choose. There is infinitely many answers to this question because I can plug in any number I would like for either x or y to solve for the other variable. So the easiest one by far that I would always suggest you do is plug in 0. And you're only going to plug it in for one of your variables here. So I'm going to go back and I don't know why I like my blue. So 5x plus y equals 6. So instead of x, I'm going to plug in 0. Okay, so like this. So when I have my ordered pair, just like I see here, I'm going to have 0 for my x. I'm trying to figure out what y is. And I do that by solving this equation. So if I say 5 times 0, well, that's 0 plus y equals 6. Well, 0 plus y is just y, so y equals 6. So I kind of quickly arrived there at 0 and 6. Again, there are an infinite number of answers for this question. If I wanted to plug in 1,000,000 for x and see what y comes out to be, I can do that. I wouldn't suggest, bigger numbers because the more you have to type in, the more the likelihood that there's going to be an answer or an error in the way you type things in, or even just calculations. So 0 is definitely the easiest bet there, but it's not the only one. All right, I'm going to go ahead and click check, and we are good to go. All right, so for this one, I'll erase this stuff. So we're told to graph the line. So in this case, what we want to do is create an XY table. So X, Y, and then in the middle here, we have the expression that we need to work out. We have to pick our plugins again. It's not telling us what to calculate out here. We just have the equation. So I always choose, I tend to go 0, 1, 2. The only time I choose other numbers than 0, 1, or 2 is if I have a fraction and I want to eliminate the fraction. And I hope that we have an example on that in the next screen or two, so I can actually show you kind of what I mean by that. So if I choose 0, 1, or 2, again, you can choose any numbers you want, but they need to fit on the graph. That's one big warning. If you chose 1,000,000 in this case, it would be correct if you worked it out mathematically, but it wouldn't fit on the graph. So be careful about that piece. So we're going to go through and we're going to plug in our numbers. So instead of X, I put 0 here. 4 times 0 is 0. And I like to cross my zeros off for whatever reason. The next one is still 4 times X, but now I'm plugging in 1 for X. 4 times 1 is 4. Now I'm going to plug in 2. 4 times X, in this case it's 2, so 4 times 2 is 8. So I have my 3 points. I really only need 2 points, but the third point ensures that the pattern is continuing because we should see a straight line here. So I have 0, 0, and then I have 1, 4, and then I have 2, 8. And if you notice, I'm going 0, 0, 1, 4, 2, 8. So I'm kind of ignoring the middle as I read these. But again, what the third point does is it ensures if I click and I click again, because you have to click twice to snap the line, it should go through all 3 points that I have there. It just ensures to make sure, yes, I did in fact do my math correctly, it's working out, and the pattern is continuing. So we'll go ahead and click check there, and we're good. All right, we're going to do a similar thing here. Okay, perfect. So we're given a fraction on this one, so I can show you what I mean by what I was saying on the last one. So again, we want to create that XY table like that. And this time I'm going to have negative 1/3 x plus 5. Now when there's a fraction, we want to try to eliminate the fraction if we can, because it makes it easier to graph. You can graph fractions. You can graph fractions or decimals by simply clicking this button and you type in what you want your x and your y to be. So if you end up with a fraction or a decimal, you can still do that. Don't think that you can't graph those. Now, you can't do it with the pencil. Those are only going to go right on top of the points. You can't go in between here. Like, I couldn't go to, 2.5. It's either 2 or 3. But I could graph 2.5 on here. If I type in 2.5 and then let's say 1, there you go. Now you can see it went there, and I just have to click plot the point, and now it's plotted, and I can close this. And it's there. I'm going to click undo because that's not actually one of the answers there. So with this one, 0 is still a good one because that's anything times 0 is going to go away. But instead of picking 1 and 2, I'm going to go with numbers that will eliminate the 3. So I'm going to go with 3 and 6 because they're divisible by 3. So now when I plug these in, I have 0 instead of x plus 5. Well, anything times 0 is 0. So 5 is what's left over there. Extend that down a little bit. And I have negative 1/3 times 3 plus 5. Well, remember, a fraction is multiplication on top, division on the bottom. So this is like saying 3 divided by 3. That's exactly what that means. This is telling me I'm dividing by 3. So that's 1. It was negative, so it's negative 1. Plus 5, that's 4, right? And then negative 1/3 times 6 plus 5. And again, we're dividing by 3 here. So 6 divided by 3 is 2. Don't forget the negative, though. It's negative 2 plus 5, and that's 3. So now I have my 3 points, and I can plot them. So I have 0 and 5, and I have 3. Oops, sorry, doing that backwards. 3 and 4. I almost got myself mixed up there. And then 6 and 3. So that does look like a nice straight line there, which is what I want. In this case, we always want them to be in a nice straight line like that. There should be absolutely no curve. When you plot points, they should all be on that line for that equation. Alrighty, continue. And we have 3x plus y, so we're just going to keep doing the same method. X, y, and we have 3x plus y equals -3. So this one might take a little bit more work in the middle because we don't have it equaling y. But what we could do is, instead of typing that in, what I could do is subtract 3x from both sides. So that way I have y equals 3 minus 3x. Now I have an expression that equals y. So that's definitely something that we want to think about when we have both variables on one side. If you move it around, which was part of our literal equations practice from last week, we were learning how to kind of manipulate the equations like that so we can get them to equal the variable we want them to equal. In this case, I want it to equal y so that once I work this out, I know exactly what to write in over here. So again, we're just going to pick some numbers, and this goes back to I can pick whatever I want, so I always tend to go with 0, 1, and 2. Again, you can go with any numbers you want as long as they'll fit on the graph when you're done. So if you pick numbers over here that are bigger than, say, 10, well, then you won't be able to graph it because this only goes to 10. And if you get a number bigger than 10 for y, again, you won't be able to graph it. So you have to be careful about that part. All right, so 3 minus 3 times 0, because that's my first x. 3 times 0 is 0, so the only thing left over is that 3 in the front. Then I have 3 minus 3 times 1, because here's my second x. So I have 3 times 1, well, that is 3. There's a negative here, so it's -3. So 3 minus 3 is 0. And the last one here, we're plugging in 2 there, so I have 3 times 2, that's 6. So even if I rewrote that, just because you can always rewrite these, I know I'm kind of walking through them out loud, but once they start to get a little bit more involved, you may want to write them out just so that you don't kind of forget what the pieces are. So 3 minus 6 is -3. And I could see that was dropping too. It went from 3 to 0, so I was expecting a negative number there. All right, so I have 0 and +3. I have 1 and 0. So I go over 1 and I stay right there on the axis. And then I go over to 2 and I'm going to drop down to -3. And again, those look like a nice straight line, and perfect, they are. Uh-oh, what did I do? Let's see, you have entered in opposite quadrants. You may have entered the opposite of the x coordinate for one of your points. 0, 3, 1 and 0, 2 and -3. Well, I don't think so. Oh, darn it, this is a -3. See? Oopsies. So this would have been -3. This would have been -6, because -3 minus 3 gives me -6. And then -3 minus 6 doesn't give me -3, it gives me -9. Because I had 3 negative and I went 6 more negative. So that was just an oops. When I rewrote it over here, I completely forgot to bring the negative over. Do mistakes happen? Of course they do. We just have to go back and look at what happened there. So I'm going to go ahead and X these off because they are all in the wrong spot there. And let's try that again. So we have 0 and -3. We have 1 and -6. And we have 2 and -9. So yeah, those are in completely different spots there. All right, let's go ahead and recheck that. Yay! So again, mistakes happen. That's perfectly fine. Everybody makes mistakes, as you can see. We just have to go back, take a look at our work. Sometimes it's a little hard to find the mistakes, so we just have to kind of start over, try again, see if we get the same answers. All right, let's go ahead and go to the next one here. Okay, so this is a little bit of a special one when we have just x equals a number or y equals a number. Well, now it doesn't really make sense to make an XY table because there is no y in this equation, or there is no x if you only had y equals a number. What it actually means is the coefficient near that number is 0. So it's still there, so we could think of it as 0y plus x equals 3, like that. We can still think of y as there, but it's disappears because it's multiplied by 0. Okay? So when this happens, you can make an XY table, but no matter what I do, x is always going to be 3. And if it was a y equals a number, y would always be that number. So in this case, since I have x equals 3, I want to go over to 3, and I want to place my dot, because that's where x is always going to be. Well, if I follow along here, and I can put dots wherever I want, along 3, if I went down to, say, this one, which is -7, I have to go over to 3 to get to this dot, which means that x is 3. Or if I go up to 6, I have to go over 3 to get to this dot. So what this is telling me is that it's going to be a vertical line if it says x equals. If it says y equals, it's actually going to be a horizontal line because we always want y to equal whatever that number is. So there are kind of special circumstances when you see just x equals or just y equals. All right. Alrighty, intercepts. So this is just the idea. If you've ever watched football, you might have heard the word interception before. And it's just, when the other team catches the ball, kind of an idea. They take it away. So when we're talking about it in math, it's where the lines cross. And what I mean by lines is the graphed line, which is usually this bright blue one here on the screen. And then we have the y-axis and the x-axis. So we're looking at where our graphed line crosses the axes, okay? And that's what an intercept is. So for the x-intercept, it's where it crosses the x-axis. So I can see it crosses right here at -4. So I type in -4 right here for part A, because that's my x-intercept. And then I do the same thing for y. Where does it cross the y? Well, I can see right here, it crosses at 4. So I would just type in 4. And that's all we're doing. We're just identifying these intercepts. These will be important later when we go to build some equations because they help us quickly build an equation for a linear function or a linear equation. Alrighty. Next. Okay, so it says find the x-intercepts and y-intercepts as lines. So same thing we were just doing, but now I don't have a visual to do this. But if you remember, if we kind of take a look back at this one, if I'm looking at the y-intercept here, and I'm looking at the origin, well, I had to go straight up to this number 4. That means that x is 0. And if I think of the x-intercept, I didn't leave the x-axis, so I went over to -4, but I'm still on the x-intercept, so I didn't go up or down, so that means that y is 0. So it's kind of a little bit opposite. When you think of it this way, doing it in an equation, if I want the x-intercept, I'm going to make y 0. If I want the y-intercept, I'm going to make x 0. And I solve both of those. So for the x-intercept, I go 4x minus 3. Instead of y, I'm going to make it 0, like that. And then I'm going to solve. Well, 3 times 0 or anything times 0 cancels out. And I get 4x equals 24. And I'm going to divide both sides by 4 because I want to undo this multiplication that's happening here. So x equals 6. So that's my x-intercept is 6. Now I'm going to do the same thing for my y-intercept. Pen is writing funky today. Let's go back. Intercept. Y-Intercept. There we go. So I'm going to write 4 instead of X, I'm going to write 0. I'm going to move that a little bit closer. Don't know why that moved over so much. Now I have 3y equals 24. So now the y is there, but the x is 0. So anything times 0 cancels out. I have negative 3y equals 24. So this time I'm multiplying by negative 3, so I just divide by negative 3. Because anything divided by itself becomes 1. 24 divided by negative 3 is negative 6. So negative 6, check. Uh-oh. What did I do? I made another mistake in here, didn't I? Oh, geez Louise. This would be 8. I'm just being silly right now. 24 divided by 3 is 8, not 6. Which, that's another piece that I really, really like about Alex, if you're, watching this part of the video, is that it does give you second chances. So if you make silly little mistakes like that, oops, I accidentally said 6 instead of 8. It doesn't immediately mark me wrong. It says, oh, try again. It gives me a couple chances here. So it doesn't just immediately give me that X on the whole problem. I get to go back. Okay, so for this one, we're actually going to use mostly just the screen here. So it says graph the line whose y-intercept is -9 and whose x-intercept is -7. Well, it's giving me the intercepts. Remember, this is where it crosses the y-axis. This is where it crosses the x-axis. So if it crosses at -9, I can just go on the y and go down to -9 there. And then if this is where it crosses on the x-intercept, then I'm just going to go on the x-intercept over to -7. And I'm just going to connect these 2 points. Boom, boom, and I have graphed the line. So that's it. That's all they wanted us to do on that guy. Perfect. All right, this last one. So we have a little bit of a word problem here. So it says the sugar sweet company is going to transport its sugar to market. It will cost $4,500 to rent a truck, and it will cost an additional $225 for each ton of sugar transported. Let C represent the cost, the total cost. So C is our total cost. And let S, and I do these little crosses so you know it's an S and not a 5, represent the amount of sugar. So amount of sugar. And we already know, no matter what, it's going to cost $4,500, right? This is a no matter what, it's going to cost this much just to rent the trucks. And then it's going to cost an additional $225 for every ton of sugar we transport. So we need to write an equation for this. So if I rent the trucks and I don't transport any sugar at all, they just sit there and I don't transport anything, it's still going to cost me $4,500. So this $4,500 has to be part of our equation. And we're working on C. We want to know what the total cost is. So C is going to equal $4,500 plus we have to add in this additional cost. It's $225 for each ton of sugar. So if we transport 1 ton of sugar, it's $4,500 plus $225. If it's 2 tons of sugar, then it's $4,500 plus $225 times 2. And then if we did 3 tons of sugar, then it would be times 3. And 4 tons would be times 4. So hopefully we're noticing a pattern there as I say this. So we have 225, but we need to multiply this by the amount of sugar we're transporting. And this is the amount of sugar in tons. So this S represents either 1 ton or 2 tons or 3 tons or 4 tons or however many we're transporting. So this is my equation for this situation. The total cost is going to be how much the trucks cost just to rent plus the additional cost per ton. So we get to type this guy in, and I'm going to be a little picky here. Make sure you're using capital letters in this one because it started, or it gave me capital letters up here. It actually, I don't think it will mark you wrong, but it will give you grief about it. It will tell you that there should be capitals there. And we want to be picky about that because as we move forward and we start using formulas that are pre-made, like the volume and the area formulas and things like that, capitals and lowercase mean different things. So you want to be very careful about mixing those two. Just because you might mix them up in a formula, that it does make a difference between a capital letter and a lowercase letter, because they literally represent something different. Okay, so now we need to use this equation to calculate the cost to transport 17 tons of sugar. All right, well, we have our S then. We know that it's going to be 17 in this situation. And we're going to multiply that by 225. And then we're going to add that to the $4,500 that is going to be our cost no matter what. So we are going to go here, and for whatever reason, they don't have a calculator open on this one, but you could probably do this one without a calculator if you wanted to. But we're going to multiply 225 by 17, and we get 3,825. And we need to add that to the $4,500 so that we get our total cost here, which is $8,325. And if the calculator is available, it's usually right here above explanation. Sometimes it does come up and sometimes it does not. I know we enabled it when we set this up, but Alex also kind of makes up its own rules based on when it's available and when it's not available. If you do need a calculator, let us know. We should have them available in the center for you to use. All right, check. Perfect. All right, so let's do this last guy here. So the sugar sweet company is going to transport its sugar to market. So very similar problem to what we just did. They're just going to give us some new numbers. So now it's going to cost $2,600 no matter what. So this is the no matter what cost, and it's going to cost an additional $100 for each ton of sugar. So very, very similar problem to what we just did, but they are just changing the amounts. Instead of being $4,500 no matter what, now it's only $2,600. So maybe this could even be the exact same company, because I'm pretty sure the other one was Sugar Sweet as well. I'm just curious. I'm going to go back and look really quick. Yep, Sugar Sweet as well. But maybe they found a better price now for running the truck. So, because obviously this is quite a bit cheaper. So we're still going to have C, which is the total cost. And we still have S, which is the amount in sugar. So amount of sugar. All right, so, and we already kind of worked out this equation on the last one here. So it's going to be C, the total cost, is going to equal my no matter what, I have to pay $2,600, plus my additional fee. And remember, it's $100 for each ton of sugar. So I need to make sure that that gets multiplied. So here's my equation. Very similar to the last one we just wrote. In fact, it's almost identical as far as the pattern there. I'm just updating the numbers. Depending on what you see on your screen, you may or may not have the same story. The story just gives us context to what's going on, but it really shouldn't change the process here. You're going to have something very similar to, this is my starting point. No matter what, I have to pay this amount, and you're going to have an additional cost. So it'll be, per ton of sugar or per mile or per hour, something along those lines. You'll have some kind of additional cost. Okay, and now they want us to graph this. So if no matter what, we're going to pay $2,600, that's our starting point. So at 0 tons of sugar, I'm going to pay $2,600. And if you notice, I can't graph that like this, but if I click on this little plot a point, then I can go, if I have 0 tons of sugar, then it costs me $2,600. And there you go. It popped up there for me. So I can click plot point and it'll stay there. So the next one, I want to see how much is going to be for the next one, because I need at least 2 points here. So I can go C equals 2,600, and they're not telling me what to plug in. I'm going to choose what to plug in to find my next point here. So I'm just going to go ahead and go with 1 ton of sugar. So this is going to be 100 times 1, which is 100. And I'm just going to add that to my no matter what cost here of the $2,600. So that's going to be 2,700. which again, I still can't quite graph on my own. I do need to use this to go 1 ton of sugar costs 2,700. And I'm going to click plot that point. Now I'm going to close this and I'm going to connect my line here so I can see the pattern. Oh, I think it wants me to expand this over. The tool is just being a little argumentative. There we go. So now we can see, and I can follow this now too, and I can say, you know, okay, well, for 9 tons of sugar, it's going to cost $3,500 because I can see that's where the line crosses here. So once I have those first couple of points plotted, I can use this to keep predicting and use it visually to see how much it's going to keep costing. So let's go ahead and check that, and we should be good to go. All right, that was section 1 of chapter 3. I will see you in section 2.